Okay, so this is MMAE review session for October 28th. I'm going to start off with sample problem 6.1. So this is a truss here with, so it has 5 joints. We're going to look for the force in each member of the truss. So first thing we want to do is do a free body diagram of the truss as a whole. So we have 2,000 pound force acting there, 1,000 pound force here. We have a pin joint at C, so we want forces in the X and Y, which I'll call CY and CX. We have a roller joint here, so that will just give us, so this is point E. So I'll call this Y, and then that's it. So those are all the forces we have acting on the truss. So if we do some of the forces, we end up with some of the forces in the X, we just have CX, which is equal to 0. And that's pretty obvious because there aren't any horizontal forces acting on the system. So more importantly is the vertical forces. So we have CY plus EY minus 1,000 minus 2,000. So this tells us the sum of CY and EY is 3,000. So we need a moment equation for this. So we have to think, where do we want to take the moment about? Obviously, we want to take it around one of the pins where we have unknowns. So either EY or CY. I think taking it at point C would be best. So if we do some of the moments about C, we end up with okay, so the horizontal distance between EY and C is 6 feet, but it's going to be, by a right-hand rule, it's going to be a negative moment. So we have negative 6 EY, and then the other two are going to provide positive moments, so plus, we're told that distance is 12 times the 1,000 pound force, and then it's going to be plus 24 times the 2,000 pound force. And this is equal to 0, so we can solve for EY here. So EY turns out to be 1,000 pound force, and from that we can plug that back into our some of the forces in the Y direction to get CY is 7,000. Okay. So those are our two. We solve for 3, 1, 2, 3 of our external reactions. So now that we have that, we can start looking at the pins, come up with the internal reactions. So first pin we want to look at, well, I mean, it doesn't really matter which one we look at first, so I'll just follow along with what they did in the book. So we have pin A. Pin A. So we're going to have a force due to the AB rod and a force due to the AD rod. And then we have 2,000 pound force acting downward. So if you look at the way rod AD is set up, so let's say this is rod AD. We know this is 8 and this is 6. This is actually just another way of writing a 3, 4, 5 triangle. It's just multiplied by 2. So we know that this is going to be 3, 4, 5. We can write that back over on the force here. We have 3, 4, 5 triangle there. So that'll help us when we're doing the sum of the forces. So let's do the sum of the forces in X is equal to AB plus, and then we're going to do 3/5 AD because of the 3, 4, 5 triangle there. And so they're both in the positive X direction, which means that we're going to end up with them being in opposite directions. So we'll just set this equal to 0. We don't know either of those yet. So we need to do the sum of the forces in the Y in order to get the value for AD. So we end up with negative 2,000 minus 4/5 AD is equal to 0. So this gives us 80 is negative 2,500. That's going to be in pounds. So then we can plug that back into our sum of the forces in the X direction to get AB. So this gives us AB is 1,500 pounds. Okay, so moving on to the next joint, we'll just look at joint D, because that's connected to A. So this is joint D. We have the force AD going up and to the left again. And then we're adding in force DE and force DB. I guess I can call it force BD and force DE. So we can determine, let's see. Okay, so we do the sum of the forces in the X direction. We're going to get components in 3 from all 3 values there. And then some of the forces in the Y. Actually, let's look at some of the forces in the Y first. This will give us, these are all 3, 4, 5 triangles again. If you look back at the values given for the distances there, it turns out all these values are 3, 4, 5. So if we're looking at some of the forces in the Y, we end up with 4/5 AB plus 4/5 BD is equal to 0. So this will give us BD is the opposite of AB, which is then going to be 2,500 pounds. So now that we know that, we can do the sum of the forces in the X to get our value for DE. So the sum is going to be negative 3/5 BD plus 3/5 BD plus DE is equal to 0. So DE is then going to be 3/5 AD minus BD. Okay, and so this AD minus BD is going to be negative 5,000, so 3/5 of that is negative 3,000. Okay. So just to recap here, we've gotten values for AB, AD, DE, and BD. So now all we need to solve for are BC, BE, and CE. So I'll do that on the next slide. So next one we want to we'll look at point B, or joint B. And this is a bit more complicated because we have forces going in several directions. Luckily we know several of these forces. So this is AD. We have 1,000 pound force acting down, and we have BC, BD, and BE. So first thing we want to do is sum of the forces in the Y. That's because we already know most of the values in the Y direction except for BE, so we can solve that easiest. So again, these are all 3, 4, 5, or all of these values are 3, 4, 5. So I can just draw that in here, 3, 4, 5, and same thing over here, 3, 4, 5. So if we do the sum of the forces in the Y, we end up with a bunch of negative values. So negative 1,000 minus 4/5 BD minus 4/5 BE is equal to 0. We know BD from the last slide. BD was 2,500 pounds. So if we plug that in, we get so for BE, we end up getting a value of negative 3,750 pounds. So that's another one. Now if we do some of the forces in X, we can solve for BC. So we have negative AB minus 3/5 BD plus 3/5 BE plus BC is equal to 0. So if you plug in all the values here, we had, let's see for a second here. So we have AB was 1500. BD, we just solved for, no, let's see, BD was 2500. And BE we just solved for is negative 3750. So this gives us a value for BC equal to 5,250 pounds. So last thing we need to solve for here is force from C to E. So we can do this from either point E or point C. For simplicity's sake, I'll just do it at point C. So this is point C. We have CY. We had CX was equal to 0, so I'm just not going to draw it. We have BC and CE, and CE is what we're looking for. So we can do this doing either the sum of the forces in the X or the sum of the forces in the Y. So it doesn't really matter, I'll just do sum of the forces in the Y. It's equal to CY minus 4/5 CE is equal to 0. And if you recall, CY was, we go back here, we'd solve for CY, it was 7,000. Let's just make sure that in the book it says it's negative 7,000, so I just want to make sure of my calculations here. Okay, yeah. So sorry, it's actually supposed to be 7,000. I just forgot the negative sign there. So plug that into this equation, and we end up getting a value for CE is equal to 8750, or sorry, negative 8750. So that's our final value. So just checking here, we have 1, 2, 3, 4, 5, 6. Okay, yeah, so that's it. There were 6 members. Actually, there were 7 members. Am I missing something? So let's see, we have AB, AD, BD, DE, and, oh, sorry, there it is. BC was 5,000. So there were 7 members, and we found 7 values, so that's the end of the problem. So now on to the next problem, problem 6.1. It's a pretty simple truss problem here. So again, start off with three-body diagram of the entire structure. So at A, there's a pin joint, so we'll just do two forces here, AX and AY. At pin B, there's a force of 84 kilonewtons acting down. And at C, there's a roller joint against the wall, so we'll just do CX. Okay, so let's just start off with some of the forces here. So sum of the forces is equal to AX minus CX is equal to 0. So AX is equal to CX. Sum of the forces in the Y, we end up with AY minus 84 is equal to 0. Sorry, miswrote this. 84. So AY is equal to 84 kilonewtons. And then we need a moment equation to get us our last value. So we're going to take the sum of the moments about point A, just because that's where most of the reaction forces are. So if we look, it's the 84 kilonewtons will provide a positive moment, so that's 84, and then the moment arm is 3, and then CX will provide a negative moment arm, or a negative moment, so you do CX, and then the moment arm there is just going to be 5.25, so that's the 4 plus 1.25 from the drawing. So this is equal to 0. This gives us CX is 48 kilonewtons, and that tells us AX is also equal to 48. Okay, so now that we have all that, this is a pretty simple problem. So the first one we want, or the first pin we want to look at is going to be C. This is just because you're going to want to look at either A or C, because there's a vertical member there. So it's easiest, since our axes are in the X and Y direction. If there's a member in the Y direction, you want to do that one. So we're not even going to look at the other point there. We're not going to look at point B. We're just going to look at point C and then move over to point A. So do a free body diagram of each of the pins. So we're going to have the force AC. We have a force CX and a force BC. And if you look, it might not be that easy to tell, but BC is actually a 3, 4, 5 triangle here. So in this case, this is 3, this is 4, this is 5. So we can easily do a sum of forces in each direction now. So sum of the forces in the X is equal to negative CX minus 3/5 BC is equal to 0. So it'll give us BC is a negative 80 kilonewtons. So that's our first one here. Now if we do the sum of the forces in the y, is equal to AC plus 4/5 BC is equal to 0. So this will give us AC is, let's see, 64 kilonewtons. That's our second value, and then we only need to solve for one more. So again, like I said, we're just going to move up to point A because we're only dealing with one angle value here. So let's see. So this is the angle 1, it's AB. Then we have AY, AX, and AC. So the only thing we don't know now is AB. And if you look at the values here, this turns out to be a 5, 12, 13 triangle. You can get that just by multiplying each of the values given by 4. So we had a value of 3 here and a value of 1.25. So 3 times 4 gives us the 12. 1.25 times 4 gives us 5. So then the other side has to be 13. That makes the sum of the forces easier. And it doesn't matter which direction we take it in. We're going to get AB no matter what. So it's just easiest to take it in the x direction because there's only one other force in the x direction. So this gives us AX minus 12/13 AB is equal to 0. Okay, and so if you plug in the value for AX, we end up with AB is 52 kilonewtons. Okay, so we had 3 members, so we solved for the 3 values. And again, if you want to write this more consistently, you can write this as 80 kilonewtons in compression, whereas the other 2, AC and AB, are in tension. Okay, so we're going to move on to the next problem here. Let me just make sure this is still running. Okay. This is problem 6.2. Similar situation here. You just have a slightly different shape. So, as per usual, just a free body diagram of the whole thing. Okay, so we have a roller at point C. Let me mark these points here. C, A, this is B. So at point C, we have a roller. So this is just going to give us force in the y direction. And at pin B, we're going to have one in the x and y. So that's our free body diagram. Obviously, if we do some of the forces in the x, it's just bx, and that's 0. So that's our first reaction. Some of the forces in the y will tell us by plus cy minus 945 is equal to 0. So then we need a moment equation. So I'll just take the sum of the moments about point B. So give us so negative 12 times 945. The 9 by right hand rule, the 945 is going to give us negative moment, and then plus, it'd be 15.75 times CY. Okay, so this is 0. So let's just plug that in. This will give us a value CY is equal to 720, and that's going to be in pounds. Okay, so if we plug that back into our other equation there, if we plug it back into the sum of the forces in the y, we end up getting By is just 945 minus 720, which is 225 pounds. Okay, so now that we have all of those calculated, we can start looking at individual pins. So we have to pick where we want to start. So like in the last problem, I would say it's your best bet to just go with either point B or point C, because remember BC is in the same direction as our forces, so that just makes it easier for the calculations. So we should probably start with point C, and then once we finish those calculations, just move over to point B to finish the problem. So it's point C. We have a force AC and a force BC along with CY. So first thing we want to do is look at the angle that AC is going to be at. So actually, let's see. So actually this turns out to be a 5, 12, 13 triangle as well. So let me just draw this in here. So this side 5, this is 12, this is 13. This corresponds to our value here. So, sorry, this isn't drawn that great, but I'll try my best here. 5, 12, 13. So that just helps us with doing the sum of the forces. So if we do sum of the forces in the x, actually we should probably start with sum of the forces in the y, which make it easier. Sum of the forces in the y is equal to CY plus, sorry, let's get that to be a plus, CY plus 12 over 13 AC is equal to 0. So we had our value for CY was 720. So if we plug that value in, we end up with AC is negative 780. Negative 780. Okay, and that's, how many we wrote this? 1 second. And that's going to be in pounds, just like everything else in the problem. So that's our first value. Now we do some of the forces in X. So this will be negative BC minus 5/13 AC. Obviously, we just solved for AC, so we can just plug that value in to get our BC. So this will give us a BC 300 pounds. That's our second one. And I'm just going to write this over here. I'm going to do, look at point B now to get AB. So there's AB, BC, BY, oh yeah, and BX was 0. So I'm just going to ignore that. Okay, so those are the three forces that we have. So again, we want to look at the size or the angle that AB is at. So this is actually another 3, 4, 5 triangle. So in this instance, this is the 3, this is the 4, that's 5. Okay. So again, that's just helping us do the sum of the forces easier. So we do the sum of the forces in the y, that will give us AP. So we end up with BY plus 3/5 AB is equal to 0. So since we know BY was 225 pounds, we can now solve for AB. So AB turns out to be negative 375 pounds. Okay, and so that's our third value. That's the end of the problem. So if you did the sum of the forces in the x, you could check your answer as well, or you could also look at point A to check your answer, but we're not going to do that now. So I'll just move on to another problem then. So we'll just move on to problem 6.3. So in this example, we have a truss here. Okay. So let me just give the measurements here. So first I'll draw, we have a roller joint here and a pin joint here. Okay. And we have a force up here of 0.92 kilonewtons acting downward. So this distance is 4 meters. The distance between these two pins is 4.5 meters. And distance here is 3 meters. So first thing I want to do here is actually just try to figure out the angles that these values or that these are at. So let's mark these points out with A, B, and C. So if we look at just AB by we can already see it's just going to be a 3, 4, 5 triangle. Just write that in here. 3, 4, 5, just from the given dimensions. And then we also want to look at AC to try to figure out what angle that's going to be at. So this turns out to be 8, 15, 17 triangle. Yes, okay, so let's just write that down here. So this is AC. So the vertical value here is the 8, is 15, is 7. Okay. So that'll just help us a lot in calculations. So do a free body diagram of the whole system. So we have a 1.92 kilonewton force acting down. We're just going to have one reaction at point B, because it's the roller. So we'll just call that By. And then we have Cy and Cx. Okay, so the problem we can obviously see if we do the sum of the forces in X, it's just Cx, and that's equal to 0. So that's our first reaction there. Now we can do sum of the forces in the Y is equal to By plus Cy minus 1.92 is equal to 0, and then we need to sum the moments. So probably the easiest is just to take it about point C. So it's going to be negative 4.5 times By. That's just from a right-hand rule, plus it'd be 7.5 times 1.92 kilonewtons is equal to 0. So this gives us By is 7.5 times 1.92 divided by 4.5. Gives us By is 3.2 kilonewtons. Okay, and then we can plug that back into our sum of the forces in the Y here to get Cy. Let's see. Cy is then going to be negative 1.28 kilonewtons. Okay, so those are our reaction forces. Again, like with the previous two problems, I'm going to recommend just looking at points B and C because one of the numbers BC is horizontal, so it's just easier not having to deal with multiple numbers that are at angles within one problem. So let me just get out of the sheet here. And I'll have to be switching back and forth. So if we look back, point B is probably easiest to figure out. There's only three forces acting there. Okay, so we have our By. We're going to have, it was 80 and BC. And then AB, just to reiterate here, is the 345. Right, okay. So some of the forces in the X, actually since we don't know that yet, we should probably just start with some of the forces in the Y. So some of the forces in the Y will give us AB. So we end up with BY plus 4/5 AB is equal to 0. AB is going to be negative 4/5 BY. Look back, our BY was 3.2. So a negative 5/4 times that gives us a negative 4. So that's our first solution there. We do some of the forces in X, that will give us BC. So we have BC minus a 3/5 AB, give us, so BC is just 3/5 AB. So that's negative 2.4 kilonewtons. That's our second solution here. And then we want to look at point C to get our last solution. So looking back, point C, we had just CY acting on it, and then BC again, and then we're going to have our, what was it, AC? Right. And AC was 8, 15, 17. Let me just try to draw that in here. 8, 15, 17. So we can do the sum of the forces in either direction. It's just easiest to do it in the Y. So we end up with CY plus 8 over 17. AC is 0. So we need to look back and see what CY was. CY is negative 1.28. So we add that to the other side, multiply by 17, divide by 8, and we end up with AC is 2.72 kilonewtons. So that's our last solution there. We had 3 members, so we'd solve for the forces in each member. So these are all pretty simple problems here. And we have a few minutes left, so I'll just go over one of the problems done in class. So we have a shape like this. With the roller support here, a pin support here. Yeah, 600 newtons here. And 400 newtons here. And if we draw this vertical here, this is 3 meters and this is 3 meters. This distance here is 4 meters. So now that we know all that, we can draw the free body diagram of the system as a whole. Something like this. Just 1 reaction at the roller, 2 reactions at the pin. 600 newtons acting here. 400 newtons acting here. Okay, so just do some of the forces in the X first. So give us Cx plus 600 is 0, so Cx is negative 600. Some of the forces in the Y gives us Cy plus Ay minus 400 is 0, so obviously we can't solve for that yet. And we'll take the sum of the moments about point C. That's just the most convenient place to take it about. So by right-hand rule, Ay is going to give you a negative moment, so negative Ay times 6 and 400 newtons will give you a positive value, so plus 400 times 3. And then the 600 will give you a positive value, so plus 600 times 4 is equal to 0. This gives us Ay 600. Okay. And so if we plug that back into some of the force equations here, we end up with Cy is negative 200. So now we can start looking at the pins. Probably the easiest pin to look at is pin C. Everything is in either the vertical or horizontal directions. So Cy, Cx. And we have, I just realized I didn't put the marks here, so just so you know what I'm talking about, we have CE and then BC. Okay, so it's pretty simple. Obviously, it's just some of the forces will just give us BC is equal to Cx, which we just said was, what did we say, negative 600. And then CD is equal to Cy, which we said was negative 200. Those are our first two solutions. And then we just need one more. Or sorry, no, we need two more. So we'll look at point A. Let me get out a new slide here. So we have point A. Reaction here. We have AB here. So so you can pretty easily tell that AB is going to be just a 3, 4, 5 triangle. Whoops, what did I do? Okay, sorry about that. So it's just a 3, 4, 5. So this value is the 3, this 4, that's 5. So first thing we want to do is sum of the forces in the Y. So give us Ay plus 4/5 AB is 0. This gives us AB is equal to negative 750 newtons. Now if we do the sum of the forces in X, end up with AD plus 3/5 AB is equal to 0. Just plug in our value that we just got for AB. End up with AD is 450 newtons. So that's two more. And we still need to solve for B. So to do that, we'll just look at point B. We have point B here, with 400 newtons acting down. We have BC, AB, and BD. And so we simply do the sum of the forces in the Y to get our B. It's negative 400 minus 4/5 AB minus 4/5 BD is equal to 0. This gives us BD is equal to 250 newtons. So that's the end of the problem. So that's all I have. We don't have enough time to go over another problem, so that's the end.